So our second skill in Unit 10 on drawing structures of molecules has to do with taking a properly drawn Lewis structure and actually determining the molecular shape. Remembering that Lewis structures are really more Lewis representations. They're structural representations. They're two-dimensional. They might infer or imply some shape, but we need to apply this next learning skill in order to really know what the shape is, what the bond angles are. So I'm going to go through a real quick kind of introduction of why this is important. This has to do with what we call Vespers Theory. That's how we pronounce that. That stands for valence shell electron pair repulsion. So that's a mouthful, but what does it really mean in words? Anytime you have things that surround a central atom and those things are atoms or lone pairs, we want to give everything as much room as possible. Just like these puppies that are trying to eat around a food dish, they will space themselves out so they each have room. We'll talk about this with electrons. We've used this terminology before. Electrons want room to roam. So we want to make sure to give that electron group as much room as possible. And that's because electrons are negatively charged. They repel one another. So whether we're talking about those electrons as being part of a bond or as a lone pair, we need to give them room. So we're going to assign codes to central atoms that are within our Lewis structures. So again, that's really important. So I want to highlight here, when we have a correctly drawn Lewis structure, we have central atoms that we're going to determine as A. So you might have with a larger molecule more than one central atom. Right now, we're just starting out with simple molecules that just have a single central atom. So that central atom is going to be referred to as A in this code. What we really then do is we just count the number of atoms and then the number of lone pairs that surround that central atom. And we create this code. So the code will be AXE, and it'll have subscripts for the number of X's, the number of atoms, and then the number of lone pairs, the number of E's that we have. So we're going to go through a few examples. We're going to take the Lewis structures that we drew in our last video, and we're going to generate the code, and then all that you need to do is use that code and look up what the molecular shape is and what the bond angles are on a table that'll be provided for you. So again, this table 10.10 is one that's already up as a resource for you, and you're basically just going to be using that to assign the code, or take that code that you've determined and to use that to determine a molecular or atomic shape. Okay, so I want to let you know what this looks like. So codes that we'll get, for example, this is a code that's AX2. That meant around the central atom, there are two other atoms, no lone pairs. Okay, so how you use this table is I might be asking you, what's the electron group arrangement? So that's going to be this first piece up here. That's how many X's and E's you have. Okay, so in AX2, there's two things. Okay, now there's only two things that those things could be, is it's going to be two other atoms if you're talking about a central atom here. So you're going to have then two things around that central atom, and you're going to then have bond angles of 180 degrees. Putting things as far apart from one another as possible is 180 degrees. Now, once we start getting here where we start having the possibility for lone pairs, look at this. When there's three things, remember a thing can be a lone pair. We're going to categorize that as an E, or an atom. That's going to be an X, right? Looking back at our code, things are X's or E's. Things are atoms or lone pairs. We're going to count the number of things that we have, and that gives us our electron group arrangement. So if we've got three things, we're going to say that the electron group arrangement is trigonal planar. Now, depending on whether those things are atoms or lone pairs is going to change the molecular shape. Look at this here. If the three things that we have are atoms, AX3, we're going to have bond angles of 120 degrees, and the molecular shape is also trigonal planar. But notice this here. If we have one of those things as a lone pair, that means our code is AX2E. There's still three things around it, but it's two atoms and one lone pair. In that case, when we think about the shape of the molecule, we have to give room for those electrons, but they don't really reflect the molecular shape, the shape of the atoms of the molecule. So the shape of this molecule is actually V-shaped. Again, both of these have the same electron group arrangement, trigonal planar. Three atoms is going to be trigonal planar. Two atoms and one lone pair will be V-shaped. And again, the bond angle for a purely trigonal planar will be 120, but if this is now a lone pair of electrons, it actually is going to squeeze those atoms closer to one another, and it's going to make this bond angle now less than 120. I'm not going to go through every single example here, but you'll see once we get to 4 electron groups, we have differences whether those things are atoms or electrons. We have one more set of tables here when we have 5 things or 6 things. All you need to be able to do is know that I have to figure out the code, and then I can use that code to figure out the shape. Okay, so we're going to have things like trigonal bipyramidal, T-shaped. Okay, and then we can see differing bond angles. So I'm not going to go through every single example here. We'll see lots of examples of these when we're in class, but I just want you to know how to use this table. And again, noticing whether we're looking for an electron group arrangement or a molecular shape, and then bond angle. Those are the 3 things that you're going to be asked about for a correct, and I can't highlight that enough, a correctly drawn Lewis structure. So all I'm going to do here is I'm going to go through the 6 examples of Lewis structures that we drew in our first skill there, and I'm just going to map on what our code is, and then we'll kind of go back and we'll see where we get that information from our table 10.10. All right, so let's take this first guy here. I'm looking at my central atom as my carbon atom there, so that's going to be my A. I see that there's 2 X's, 2 atoms that are around that central atom there. So I'm going to have AX2, and there's no E's, there's no lone pairs on that carbon atom. Okay, so when I figure out that the code is AX2, what I then do is I come over to this table and I find AX2. Okay, AX2. That means my electron group arrangement is linear, and my molecular arrangement is linear with 180-degree bond angles. Okay, so putting and mapping that information on here, I've got for my, let's see, we're going to call this our electron group arrangement, right? So my electron group is going to be linear. My shape of my molecule is going to be linear. And then my bond angles are going to be 180 degrees. Okay, so hopefully you saw how I got that information. Let's go through with these other guys here. Looking at this guy, here's my central atom. It's only bonded to 2 other atoms, so it's actually going to be the same as this guy. It's going to be AX2 as well. So I'm not going to bother writing the same information here. That's also a linear electron group arrangement, a linear molecular shape, and bond angles of 180 degrees. All right, let's take this next guy. Looking at my central atom here, that's the nitrogen, I've got 3 atoms and 1 lone pair. So if I write the code for that, around my central atom, there are 3 atoms and then 1 lone pair. So that's AX3E. Coming back here, AX3E is going to be right here, okay? So I would say that the electron group arrangement is tetrahedral. The molecular shape is what we call trigonal pyramidal, and the bond angles are going to be less than 109.5 degrees. Okay, so let's go ahead and put that information in. So again, we're going to have an electron group that is going to be tetrahedral. And remember, you'll have this sheet available, so you don't need to worry about remembering how to spell these or any of that. My molecular shape, right, that's going to be my trigonal trigonal pyramidal, right? So we've got trigonal pyramidal here, right? Trigonal pyramidal. And then my bond angles are going to be less than 109.5 degrees. Molecular shape is trigonal pyramidal. And then my bond angles are going to be less than 109.5 degrees. Okay? So one of the things that we'll practice a little bit in class, but I want to kind of show you what we'll have here. One of the ways that we can draw and represent molecular shape here is I can use what we call wedged and hatched bonds to show things. The wedged bond, which is what we have right here, is going to show things pointing out of the plane of our paper. Okay, so if I'm going to put my fluorines here, and then I got to give room for my lone pair of electrons. Okay, So we'll practice sort of drawing these like this. It's a way to kind of show structural representations in two-dimensional space, but drawing it using sort of three-dimensional representation. All right, going through these a little bit more quickly here. We've got a code of AX3 for this guy. If we look up AX3, AX3 is going to have a trigonal planar electron group arrangement as well as a trigonal planar molecular shape. So this is trigonal planar. And that's the same for both the electron group and the molecular shape. Okay. Trigonal planar is going to have bond angles of 120 degrees. So again, those are pieces of information you'll have to provide along with a correct Lewis structure. Again, a little bit more quickly here, we've got AX5 for this last guy. This is going to be what we call trigonal pyramidal. And one of the things I hope you'll notice is that when it's all atoms that are around it, not lone pairs, the electron group arrangement and the molecular shape are the same name. Okay, so this is going to be trigonal pyramidal for both the electron group arrangement and the molecular shape. And our bond angles here, because we've got two different bond angles to consider, they're going to be 90 degrees and 120 degrees. Let me just kind of go back here so that you could sort of see this. If we look at this guy, AX5, right? That's this guy right here. We can see that this is going to be a 90-degree bond angle. That's a right angle. But when we consider the bond angle between these guys, that's going to be 120. So that's why we have to list two bond angles for there. All right, last one here. Make this video short here and wrap us up. This is going to be AX2E. Even though it's not a lone pair of electrons, it's only a single electron, we still have to give it room to be there. So that's going to be AX2E. Remembering anytime we have that one of those groups as a lone pair, or in this case a radical, we're going to have a different electron group arrangement as we do a molecular shape. So this is going to be trigonal planar. For our electron group arrangement, it's actually going to be V-shaped, or sometimes referred to as bent. For our molecular shape, it's going to have bond angles that are less than 120 degrees. Let me just show you that one real quick here. Okay, so that's going to be this guy here. We've got AX, we got three things. So we're going to have trigonal planar for our electron group arrangement, V-shaped or bent because we need to give that radical some room to be. And so because we've put that lone pair up there, that's going to actually be pushing down a little bit here. It's going to make this bond angle be less than 120 degrees. We talked about that already. So one of the things I hope you'll see is that that's going to be a pretty easy thing to do once you have a correct Lewis structure. But hopefully you'll notice that the importance of having a correct Lewis structure is really, really key here. All right, and that represents the end of skill 2 here in learning how to think about shape, and then we'll get to polarity of these structures in our last skill.